Hello, good day to you everyone, and I welcome you to the another episode on Moldflow's tips and workflow. In this episode, we are going to discuss about the another enhancement for the Moldflow release 2024. We're going to discuss on the shrinkage corrections for the 3D. I'm talking about the something called as a shrinkage adjustment that we have introduced with the Moldflow 2024 release, and that is referred as in a short form as STAMP. STAMP stands for the Shrinkage Tested Adjusted Mechanical Properties. Let's look at the enhancements and how it is going to impact onto the warpage results. So Moldflow product has close to 13,000 thermoplastics materials, and we continue to grow our library. And these efforts has not come in a short duration. It took over the last 30 years where we collaborated with our partner lab to enrich this data. And it's the most accurate data. The reason is that it is actually tested data. And for over 5,000, I would be more precise to say that 5,773 materials we have tested for the shrinkage using the real injection molding machines and the plaque with the different molding conditions and the thicknesses, as you can see onto the right hand side of the screen. And Moldflow has used these measure shrinkage data to improve the warpage predictions for the midplane and dual domain. And we did the something called as a correction or the calibrations with a method called as a CRIMS, that stands for the corrected residual in mold stress data. So with the release of 2024, we thought of using the same data to improve the shrinkage and warpage predictions for the 3D model. Till 2023 release, we were using a mechanical data to do the prediction for the warpage. So with the 2024 release, we have now introduced a CRIMS in the form of STAMP, that stands for the Shrinkage Tested Adjusted Mechanical Properties. And let's see how does it impacts onto our warpage results. So new STAMP model that we are referring is a non-default model at this point of time. So if you see that material already have a shrinkage properties like you see on this, go on to the material properties or the details, I'm sorry for that, and then you can click on the shrinkage properties. You should be able to see that if it is having a shrinkage properties, all the shrinkage data is there. Probably you have to go and change as a shrinkage tested adjusted mechanical properties or STAMP. That by default it's not on, it's always been set to the residual stress model, uncorrected residual stress model, and it's implemented for the semi-crystalline and amorphous material, all fiber fill types, that's long, short fibers, spherical or pellets, etc. So currently it's non-default, so the user has to go and set it and take the advantage of the shrink options. And the question arises, does it need any additional material test data? Also, no additional test data is needed. It just takes the informations from the UDB file. If it has the CRIMS data, it pulls as the CRIMS data, and then we try to apply this correction factor for the 3D mesh. So, and it's already been tested in our labs. So this shows the correlations between for the material which has been measured, or the sample which has been measured for the shrinkage, and versus the 2023 with the residual stress model and the STAMP. The graphs that you see on the side on the left hand side, it's for the flow direction versus the transfer directions, and probably you will see a substantial difference with the stamp properties coming in. And stamp captures the anisotropic or anisotropy trends much better when the leg thickness changes. And this is a correction percentage residuals, or we call it a error percentage residual stress versus the stamp for tested for almost like 65 unfilled materials. The better it falls in this side of the curve, as is better we have lesser percentage error. So this is tested for both like an filled material and unfilled material before we go and put it into the actual reality. When I say actual reality, before it goes on to the commercial release. And validation paper is available. If you need an access, do let me know, or it's available onto our website as well, so you can go and download it from the Autodesk Moldflow website as well. And this is a validation case that you will find it in the validation paper, the part molded in our lab, and you can see that the way it has been buckled or twisted, and it shows a maximum deflection around of 17 mm. Now the same analysis was run using a previous version, that is Moldflow 2023, using a residual stress. Incorrect trend was observed, clearly misses the real effect over here. And the Moldflow 2024 using a stamp, a correct trend, and the magnitude is in good correlation, not exactly matching, but if it's correlation, 17 mm versus the 16 mm, close to 16 mm that we found with this one. Let's go in the software, and I'll show you how does it gets activated and show. So I'm into the comparison. Let me put it down, this one, or I'll just minimize it over here so that I can show it later part. So I have a model, a simple model that I usually use it for the demonstration purpose. It's like a small enclosure type of thing, and roughly thickness of around like 2.5 mm or close to that. And I'm molded with an ABS material with having a shrinkage properties in this. This is a generic ABS material that you will find it into the database, and this has been tested at Autodesk Moldflow Plastic Labs, and it has a shrinkage properties as well. And what I'm going to do is you have to, when you select the material, after selecting the material, go into the process settings, in advanced option, into the molding materials, edit, and then shrinkage properties. You have to change, since this is not on by default, you have to go and change it from the uncorrected residual stress to the shrinkage tested adjusted mechanical properties. So this has to be done manually. No default, though you have to go for a warpage, though your material has a shrinkage properties, unless until you select the stamp, it is not going to apply that corrections, and hit OK, and you ready to run the analysis for this one. Now the question arises, how does it differs from the no versus? So I have run an analysis where I have same material, but in this case I have not selected the shrinkage model. I just gone with the default uncorrected residual stress, and let's see how does the warpage particularly that influences a lot. And I'm going to put it in tile. I have logged the results. Let me off the part beams in the fit system. So on the right hand side is with the stamp, and the first one is no stamp. Okay, you can see that this is no stamp onto the left hand side, and the right hand side which is with the stamp. Same processing parameters, nothing difference, exactly the material, just not selected the shrinkage in this case. Let's go and check out the deflection results. and yeah, I have put it best fit, but if you want you can just go and select the anchor plane. But I could really find it out that with the stamp I have a little higher magnitude. I would say that difference has reduced. If you say 0.11 to 3.7, the difference has been reduced over here. But in this case, again, it's not that very significant difference over there, because it is just adjusted the scale over here, I would say. Yeah. And if I try to check out the area, so I am going to use the leverage over here, histogram over here, to find it out that area of the higher shrinkage. So I just scale it down, and I could say that, hey, with the stamp, this area is particularly having a much little higher deformation or deflection compared to what I cannot find it or miss it with the stamp. Now I run the similar thing with the fiber and without fiber. Let's look at that as well. I'm not going to save this one, and we'll come back again. So I run it with the fiber as well, with the stamp and with no stamp. So I selected the default material from the library, that is a generic polyamide. It's a short fiber material, and let's see the results for it. How does it the difference looks like? I'm just off the front and go into the view and going at tile, log all views and log all plots, and I'm going to on. This is the polyamide one with the polyamide material, and one is without the no stamp, and other is 35% glass filled. And if you go in the properties of the filler fiber, yes, and details, it's yeah, L by D ratio is 25, so it's a short fiber material that you can find it out. So in that case, let's see that how does the difference works out there. In that earlier one, the stamp was having little higher deformation values compared to this one. So with the stamp now, here in the fiber case, the deformation, and I have used the anchor plane here, that is a better way to look at it. So it will be a fair comparison exactly. So in case of the stamp is showing a value of 0.57 versus with no stamp it is showing the value of 87. And if I apply the shrinkage on the top of it, say deflection, and then we apply automatic shrinkage, or I would say that I would apply a shrinkage of around like say 0.5, or let's keep it like an isotropic, so of 0.6. I'm going to apply it for both the models, and let's see, yeah, it's got applied for both the models, and you can see that this has reduced to 0.5, but this guy has on the stamp is 0.078, and we applied the shrinkage to the both the parts of this one. I hope you will see a difference, and next time when you're probably using a warp analysis, try to use the stamp as a part of your warp analysis when you're working on a 3D model. Thank you for your time. It was a little longer video, and hope it was useful for you. Talk to you soon again.